Hello, comrades. This lecture is going to be on logic, the study of reasoning and argument. And it's going to go over formal logic, and then it's going to go over informal logic and fallacies of informal logic. This will be in the philosophy playlist. Just as mathematics is the tool of science, so logic is the tool of philosophy. There is formal deductive logic, concerned with the study of valid forms of deductive reasoning. There is also inductive logic, concerned with the kind of inquiry and reasoning typical in life and some of the sciences. And then there is informal logic, which constitutes the many kinds of reasoning employed in debate, in law and politics, in the setting out and defending of thesis, and in any branch of discursive inquiry, and in the fallacies and rhetorical devices typical of such debate. In informal logic, both deductive and inductive logical considerations apply. Important to informal logic is the identification and avoidance of informal fallacies of reasoning, which we will discuss later in the video. Those that do not rise because of the form or structure of the argument, or reasons to believe that something is true itself, independently of its context. In informal deductive logic, the concept of form, as the name implies, is central. This is what I learned from my professors at Arizona State University and Liberty University. Formal deductive logic studies not individual arguments, which are reasons to believe why something is true, but types of arguments, to see which type is so structured or formed that, if the premises are true, that the conclusion is guaranteed to be true also, independently of subject matter. This is what valid means. It is a concept that implies only to the form of arguments, not to their content. An argument is sound if, in addition to having a valid form, it also has true premises, if both its content and its form are factual. Thus, it is that the sounding or soundness of arguments is in a part a matter of the facts, those asserted in the premises, and partly a matter of how the argument is formed or structuralized. In other words, formal deductive logic is about form. Its aim is to identify which types of argument are valid in virtue of their formality, so that if true premises are supplied, that form will guarantee a true conclusion. Inductive arguments, by contrast, only make their conclusions probable to some degree of variation. That the degree of probability can be very low despite the argument appearing plausible can be shown by an example of the simplest form of induction by simple enumeration, in which a whole general conclusion is inferred from a limited number of particular premises. This swan is white, that swan is white, the next swan is white, so all swans are white. And in fact, some swans are black, some are black and white. Inductive inference always goes beyond what the premises are, whereas deductive inferences contain no new information in the conclusion, which is simply a rearrangement of the information supplied in the premises. Consider, however, all men are mortal. Socrates is a man. Therefore, Socrates is mortal. The terms occurring in the argument have been redistributed in order to yield a conclusion. But although there might not be new information in the conclusion of the deductive argument, it can nevertheless be psychologically informative. This is shown by the story of the Duke and the Bishop. A famous duke was once the guest of honor at a country party hosted by a duke. At one point, the duke left his guests to order something from his servants, and the bishop entertained the company by telling them that when, long ago, he was a newly ordained priest, the first person whose confession he heard was a multiple murderer of an especially vile kind. The duke thereupon returned, clapped the bishop on the shoulder, and said, "The bishop and I are very old acquaintances. In fact, I was the first person whose confession he heard." The rest of the guests left hastily. Evidently, they were logicians. The first systematic study of logic was made by Aristotle. With additions and extensions, especially by logicians of the medieval schools, his logic remained an apparently completed science until the 19th century. But then, in the hands of the mathematicians Augustus de Morgan, George Boole, and especially that of Gottlob Frege, It was transformed into mathematical or symbolic logic, and thus was an instrument of far greater range and power than Aristotelian logic. One of the innovations that made this possible was the development of a notation for expressing more and more complex notations. The notation standard now is derived from one first devised by Bertrand Russell and Alfred North Whitehead in their Principia Mathematica. Aristotle logic rests on three so-called laws of thought: the law of identity, which states A is A; the law of non-contradiction, which states not both A and not A; and the law of excluded middle, which states either A or not A. Augustus de Morgan showed that the latter two are different ways of indicating the same thing. See the square of opposition to understand how inferences were once explored in the framework of Aristotelian logic. We have given S for subject and pre for predicate. We have universal affirmatives, all S is P; universal negatives, no S is P; particular affirmatives, some S is P; and particular negatives, some S is not P. And yet again, the subject is S and P is for predicate. We have contraries, and entailment, and subcontraries, and then contradictions. Arranging them thus allows one to read off the immediate inferences. A entails universal affirmatives entails particular affirmatives. Universal negatives entails particular negatives, and universal affirmatives and particular negatives are contradictories as universal negatives and particular affirmatives, and universal affirmatives and universal negatives are contraries. They can be false together. With this simple ideas in mind, the main object of study for Aristotle and his tradition of logic was the syllogism, an argument form in which a conclusion is derived from two premises. So you have one premises, another premises, and then you have the conclusion from the two premises. In his prior Analytics, Aristotle defined syllogistic reasoning as a discourse in which certain things have been supposed, something else necessarily follows from them, or it can be deduced from them because they are so. Notice generalizations and particular statements in the premises and conclusions of categorical syllogisms. The Aristotelian tradition classified all the forms of the syllogism according to the quantity of all or some, quality, affirmative, negative, and the distribution of the terms in the premises and conclusion. And then from there, they devised mnemonics for 256 identified. And of these 256 forms identified, only 19 are actually valid, and even some of the 19 are controversial. The new symbolic logic is a far more powerful and extensive instrument than this traditional syllogistic paradigm, and we have that in Bertrand Russell and Alfred North Whitehead. They are extremely useful in the sense that they can clarify things. Then we can get into truth tables. I really don't want to get into truth tables, and so I'm probably just going to skip this entire table. If you really want to understand truth tables, you can just look them up. I've had to do them in my philosophy courses, and so I'm not going to entertain that here. And really, it's just from these truth tables, it's just basically a simple logical calculus. And so with these simple elements of truth tables, the intuitive use of brackets to keep all things clear, forms of arguments can be explored for validity and invalidity. So letters standing for propositions, sets of symbols coined to show relationships between them, and all of that. From the premises, one can always deduce a conclusion no matter what truth values are assigned to the premises individually. And note that a lot of the components are really important to understand if you are to have a valid and sound conclusion. because things can be valid and not be sound. So, like I said, one can use truth tables to test for the validity of certain statements and their conclusions. And one will find that the first fallacy is a fallacy called the fallacy of affirming the consequent. Of course, if you want to look into that, you can look into the fallacies affirming the consequent as well. And that is a logical fallacy. As a second example, it's a logically valid form of inference, as its truth table will show, but it is known as modus tollens. These are the rudiments of the logical propositional calculus, which deals with arguments involving whole propositions. But the real work begins when one adds a few powerful devices to this calculus, transforming it into the predicate calculus by getting inside propositions and seeing what they're made of. This is important given that the propositions assert that all or many or a few or some or at least one of a certain thing has a certain property, and we wish to understand validity in terms of this finer degree of structure using a quantifier, or how many expressions there are. So to this end, lowercase letters from the alphabet are used to stand for individual things, and the quantifier symbols are used to denote respectively all things and at least one thing. This latter doing logical duty for all other quantifier expressions, short of all, for example, some, many, the majority, a few, 3, 4, a million, and so forth. Uppercase letters form earlier in the alphabet stand for predicate expressions, and then as well. So equipped with supplementary rules allowing general expressions of the form to be instantiated to give individual experiences of the form to represent a particular individual statements or arguments can be tested for validity as before, and thus monens ponens represented might appear quantifiable, but this is an instance of modus ponens. Like I said, you might want to discover fallacy concerning affirming the consequent and modus ponens. But discussion of inductive logic often occurs in connection with discussions of scientific methodology, for the obvious reason that inquiry concerns contingent matters of fact and the process of formulating a hypothesis or a prediction and then testing it empirically can never have the conclusiveness expected in deductive logic, except perhaps when a hypothesis had been shown definitely to have been mistaken. The interesting thing about inductive logic or reasoning is that it is always invalid from the point of view of deductive logic. Its conclusions always go beyond what is licensed by the premises. Accordingly, much of the debate about induction concerns the sense in which it can be regarded as justified. A sticking point seems to be that the only available justification for induction is itself inductive, namely that it has worked well in the past. If this is not to appear to be merely circular, then the underlying assumption that the world is a consistent realm in which laws and patterns of occurrence remain stable and reliably repeat themselves has to be accepted as a general premise. It attempts to justify this premise can only themselves be inductive, so if they are made, they simply reintroduce the circularity of the assumption that is intended to make it virtuous rather than vicious. Inductive inference can take a number of forms. Induction by simple enumeration has been noted. There are also more generally better inductions taking the form of causal inferences, statistical and probabilistic inferences, and arguments by analogy, all of which, when responsively controlled and their defeasibility accounted for, are of use in practical terms in scientific investigations. Opinion polls are a great example to a reasonable degree of reliability of how effective controlled induction can be. If it is rational to take the conclusions of inferences seriously, that fact justifies induction. A celebrated twist to the debate about induction was given by the American philosopher Nelson Goodman. He argued that the problem could be recast as one about how we justify thinking that our description of things in the future depends on our description of things now. So that is the end of the section on logic. Now we can go to the fallacies of informal logic. In addition to inductive logic and formal deductive logic, there are other domains of this science in which logical principles and motions or of notions are put to work in exploration of allied ideas. We've gone over the fact that you can set up basic syllogisms from like Aristotle and truth tables and such to use inductive logic. But fuzzy logic is what's considered or concerned with domains of this science in which it tries to convey or contain vague terms and imprecise concepts. Intentional logic is concerned with the domains where context violates original workings of logic. For example, by inferring with the reference of certain terms. There's the ontic logic, which is concerned with reasoning chiefly in ethics, involving ideas of obligation expressed by such words as must or ought. There is many valued logic in which there are more than just the two truth values, true and false. There is paraconsistent, which contains and accepts and manages contradictions. There is epistemic logic, in which the operators believe that and knows that something has occurred, and those are the different types of what's considered fuzzy logic. We have fallacies of informal logic. Like I said before, there's the fallacy of circular reasoning. If I were to assume the premises, what the argument claims to prove, as a conclusion, without an actual demonstration or observable or experimental, that they are true. That is a fallacy of circular reasoning. Some fallacies turn on the illegitimate use of emotion. For example, one can be argumentum ad baculum, or baculum, which is appeal to force, to threaten another to do what one tells to believe and what one says. In other words, the existence of a divine command morality or imperative found in many communities of religious belief. We have argumentum ad misericordiam, which is appeal to pity. The whole, I will be upset, troubled, and or miserable if you do not believe and or do what I say or believe. I am poor, I am offended, I am from a minority, I have been discriminated against, etc. Associated with this is the idea that people who or have been victims of circumstance are good or right in their words or deeds, regardless of what they say, and can therefore be excused for being bad or wrong in their words or actions. The third is prejudicial use of language. It is if I were to use euphemisms in order to conceal the real purpose and intention of something. An example would be admin's death squadrons in history were called public safety units. It was used a euphemism to completely detract from what it actually was. Another one is like the CIA, the Central Intelligence Agency, which calls the assassination of unfriendly foreign leaders extreme prejudice. Other fallacies include appealing to what everyone thinks, argumentum ad populum, or to what a people in an authoritative position think, argumentum ad verecundium, or the claim that no one knows the answer, so then giving you the right of leisure to believe whatever you want or like. This is an argument from ignorance, argumentum ad ignorantium. And none of these arguments are good and sufficient grounds for accepting a view or believing anything. And so, fallacies of informal reasoning are too often deliberately and indeliberately employed in arguments and are often used to persuade and coerce people into belief or a particular way of thinking. Very frequently, I find myself and others reasoning very awful without realizing that we are actually ourselves committing one or several such of these fallacies. Informal logic concerns not only the technical matter of forms of reasoning, but all things involved in real-life discussion and argumentation, considering rhetoric, persuasion, exhortation, disagreement, inquiry, thinking things through, working things out, and making decisions, putting forward a case in the courthouse, in the classroom, in the marketplace, all spheres of life. So a pertinent consideration in informal reasoning is the detection and avoidance of fallacies for everyday usage. In Principles of Sound Reasoning, we learn that an argument can be valid if it in its form, but unsound, either because one or more premises are false or because a fallacy has been committed. Several fallacies explained and examined would be the fallacy of equivocation. That's if I were to use a word in two different senses. There's the fallacy of false dilemma. If I were to offer an alternative, which pretends to be exclusive in the sense that no other options are possible, but in fact there are other options that do indeed exist. The slippery slope fallacy of informal reasoning is if I were to assume that just because there is a cause, another effect will follow. And as well as the known that correlation does not necessitate causation. There's also the straw man fallacy. If I were to present a point of view by representing it in its weakest and or worst formulation as something easy to be knocked down. So these are some examples of informal reasoning, and we've gone over inductive logic, deductive logic, and how we can come to valid and sound reasonings, and in our logic have argumentation or reason to believe why we should hold something to be true as opposed to not. And any claim that we have has to have sufficient evidence to warrant the belief in that claim. We can't just say claims and then have belief in those claims. We have to have evidence for those claims. And we do that through deductive and inductive reasoning. Thank you for watching this video on logic, and I hope to see you in the next video.